Good morning, everyone. Okay, so let's start with our session. Today will be the last day for the discussion of the graphical method that we have continued since I guess more than 3 to 4 lectures. So today, in the half portion of the lecture, we will be having the discussion of the graphical method. We will be having one example discussion, and then I will be directly starting with the theory of the simplex method. That will be the next method that we are going to learn in our linear programming methods. Okay, so let me just share the whiteboard screen and quickly you can start with this particular example. I hope the whiteboard screen will be visible to you all. You are having 5 minutes to just develop the mathematical model. Then we will be having the discussion of the mathematical model, and then I will be again giving you 5 more minutes to have this graph. Okay, so let's have the discussion for the mathematical model. I have received two responses till now. So it says that a firm plans to purchase at least 200 quintals of scrap. So the firm is planning to purchase at least 200 quintals with high quality metal X and Y and a low quality metal Y. It decides that the scrap to be purchased must contain at least 100 quintals of X and not more than 35 quintals of Y. So over here we are having both the criterias, at least and not more than. So at least means less or equal, at least means greater or equal to. Let me write over here. At least means greater or equal to and not more than. That means less or equal to. The firm can purchase the scrap for two suppliers A and B in unlimited quantities. The percentage in terms of the weight is given over here. The price of A scrap is 200 rupees per quintal and B is 400 rupees. So what is our objective function? Can anybody tell me? Or before that, what is our decision variable? What could be our decision variables? What are our decision variables?
Sir, X1, X2.
Okay, what is X1 and what is X2?
Sir, the quantity of scrap which is bought from supplier A, that is X1.
Okay,
And sir, similarly, from supplier B, it will be X2.
correct. So quantity that is being brought from supplier A is X1 and that from B is X2. So these are our decision variables. Now let's focus on the objective function. So what could be our objective function? Maximization or minimization?
Sir, minimization. Minimization.
Minimization, correct. Why? Because it's given that the price of A scrap is this one and B is this one. So that means the firm is purchasing from the suppliers. So for a particular firm, this should be the minimization. Instead, if it was been given in terms of the supplier's perspective, then it will be the maximization. So for a particular question, you can mold the questions according to the requirements. So for a firm, it's minimization. For a supplier, it's maximization. Okay, so minimization of 200 x1 plus 400 x2. This would be our objective function. The constraints are, if you read over here clearly, that the scrap needs to be purchased at least 100 quintals of X. So from A, we are purchasing X1 and from B, we are purchasing X2. So for the metal X, our purchase should be at least 100. So it should be greater or equal to 100. And for Y, our purchase should not be more than 35 quintals. So it should be less or equal to 35. So if I can just generalize it, it should be 0.25 x1 plus 0.75 x2 must be greater or equal to 100. Second is 0.10 x1 plus 0.20 x2 should be less or equal to 35. Any other constraints that are left over here?
Yes, sir. It is x1 plus x2 greater than or equal to 200.
Correct. Greater than or equal to 200. Why? Because it's given that at least 200 quintals. And then the non-negative constraint, that is x1, x2 should be greater or equal to 0. So if we can just take this particular constraints functions in this graph, then let's save this graph. But over here we can see it's in the decimal point. So what we can do, we can convert this thing in the whole numbers by just multiply the equation by 4, multiply the equation 2 by, for example, you can multiply by 10. So equation 1 will be 0.25 multiplied by 4, so it will be 1 x1 plus this multiplied by 4, so it will be 3x2 must be greater or equal to 400. The second equation will be multiply it by 10, it will be x1 plus 2x2 must be less or equal to 350. And the third constraint remains as it is, that is x1 plus x2 must be greater or equal to 200. Now drawing the line over here. So for that we would be taking the ruler. So let me just take it. And before that I need to scale it. So how I can scale for this thing, I will be taking x1. Uh, okay, I hope I haven't made any mistake in the multiplication. And this will be x2. For the x2, I will be scaling up. Okay, this is x1 and x2. Okay, so what will be the points through which this particular line will pass? Can anybody tell me what could be the points through this line can pass? X1 plus 3x2 greater or equal to 400. So which could be the 2 points? We require 2 points for the line. 0, 133.33. Okay. So let me just write it 0, 133.33. And the other point will be 400, 0. 400, 0. Okay. For the second, 0, 175 and 350, 0. Okay, 0, 175 and 350, 0. The third will be 200, 0 and 0, 200. Okay, so for this we can just see that our x1 and x2 both are out of the range that we have just seen over here. So let me just scale this particular x1 and x2 by some value. So let me just see if I can just accommodate by 40, scaling by 40. So it will be 40, 80, 120, 160, 200, then 240, then 280, then 320, 360, and 400. So I'm just writing multiply by 10. Over here, let me just erase this 0. Okay. So what I did, I just scaled it out to 40 range. So multiply by 40. I've just done multiply by 40. Same thing over here, 40, 80, 120, 160, 200, 240, 280, 320, 360, and 400. Okay. Now let's start drawing this line. X1 plus 3x2 greater or equal to 400. So 0, 133.33. So it will be somewhere over here. Now over here in this type of the questions, you will be required to solve the equations. And the second point will be 400, 0. So it will be over here. So just take the scale over here, joining these 2 points. Let's join these 2 points. Okay, those who have already drawn this thing, please find the intersecting points 0, 175 for the second. I will be drawing 0, 175 over here and 350, 0 over here. So let me just draw it. For me, it will be taking some time to adjust these scales. And for second 200, so it will be angle 45, 200, 200. Okay. So which will be our main focus in this? Which will be our feasible region? Which will be our feasible region in this entire set of the lines? Okay, so for the first line, that is the green line, it's greater than or equal to. So for green line, it will be the above region. So for the green line, it will be above region. For the blue line, it will be below region. For the blue line, it will be below region. And for the pink line, it will be the above region again. So that means this small portion, if you can just see this small portion, will be our main focus. I'm just highlighting it. The intersecting portion, this small highlighted portion will be our main focus. The small intersecting portion will be our main focus. Anybody having any confusion in selecting this particular portion, because I received 2 to 3 answers and I didn't find the correct one? See, for the green line, we would be looking the above portion. For the blue line, we will be looking for the below portion. And for the pink line, again, we will be looking for the above portion. So the small segment that we can see, the triangular small segment that we can see will be our feasible region. If anybody didn't understand it, then please ask me, because this is the reason I took this particular example, because in this particular region, this question, we are having the exposure to the less or equal to and greater or equal to both the signs. So for that, it is necessary that we should be quite comfortable enough to solve this type of multiple inequalities in a particular question. Okay, so with this thing, I will be ending this particular graphical model, but I hope you will be finding these 3 points, these 3 intersecting points, you will be finding it, and then you will be calculating the solution for the corner points, and then you will be calculating the feasible and optimal solution. So you need to calculate for all these 3 points. These are the 3 corner points. So for these three corner points, you should be calculating the feasible solutions, and from the feasible solution, whatever the answer will be minimum, you will be calculating the optimal solution. So this will be the thing for your graphical method. Anybody having any doubt in this graphical method? Anybody having any doubt in this graphical method? I guess we have taken the ample examples to learn the mathematical model development also. Okay, now let's move to the next method. But by that time, I want the acknowledgement from everybody. If you are having any doubt, then you can ask me right now. I want the response from all. Is it clear?
No, so could you please repeat the part of calculating the points in the tram?
Sorry.
Could you please repeat the part of calculating the points between the triangle and the primary maximum and minimum?
Okay, so for this example or the generalized method, I should be repeating.
You can repeat the generalization.
I'm not getting your voice clearly. Can you please write in the chat box because it's lagging somewhere. So please write in the chat box so that I can understand it clearly.
Okay, so
Okay, so how to find the point? So let me just quickly. Okay, so you are asking for this particular example or the generalized for any of the example? Okay, so I will be repeating how to find the points. Fine. So the first step, I would be just writing over here what are the steps that you need to follow for the graphical method. So the first step is to build mathematical model. Once you build the mathematical model, you will be having the decision variables, you will be having the objective functions, and you will be having the constraints. So you will be having these three things with you. Now, after having built the mathematical model, you need to convert inequality to equality for plotting lines. So for example, I'm just writing over here example. If you are having 10x1 plus 20x2 is greater or equal to 30, let's say this is the example which we are considering. 10x1 plus 20x2 is greater or equal to 30. So what you will be doing, you will be converting this inequality into equality. That is 10x1 plus 20x2 is equal to 30. So we have converted this inequality into equality. Now, the third thing that you need to do is find points through which line will be passing. So how can I find the points through which the line will be passing? So for drawing a line, I will be requiring 2 points. Minimum 2 points are required to draw a linear line. So for this, I will be putting x1 is equals to 0. So if I put x1 equal to 0 in this particular equation, then I'll be getting x2 is equals to 1.5 So my one line will be 0, 1.5. And now put x2 is equals to 0 in this particular equation, this same particular equation, then x2 equal to 0. So I will be getting x1 equal to 3. So 3, 0 will be my another point. So from these 2 points, I will be getting a particular line that will be passing. So likewise, you construct all the lines on the graph. Construct all the lines on graph. Construct all the lines on graph. So likewise, you need to construct all the lines on the graph. So once you construct all the lines on graph, the next point that you will be having is to find feasible region. So what is this feasible region? It will be the intersecting region of all lines with inequality constraint. So now if you have plotted the line from these 2 points, so let's say this is the particular line that you have drawn. In the original question, it's greater or equal to, so it will be the above portion of this line. So that means with reference to the first equation, let's say this is the first equation, this will be our feasible region portion. For this particular line, this will be our region that we will be targeting. Similarly, you might be having some another line, let's say passing from this one, let's say this line, and you will be having the bottom all the points. So let's say this particular line is having the inequality as less or equal to. Let's say this line is having the less or equal to inequality. This line is having greater or equal to equal. So this particular portion will be shaded. The intersecting portion will be this one. The intersecting portion will be this one. This entire portion will be your intersecting portion. Now for the feasible region, you find corner points, all the corner points. Corner points are nothing but the points where the multiple lines are intersecting. So they are all the corner points. Next step is from corner points, find corner point solution. Corner point solution. So you put all these corner points that you will be getting in the form of x1, x2. You put the values in the solution or in the objective function. This corner point solution is also called as the feasible solution. Feasible solution. From the feasible solution, from feasible solution, if the problem is the maximization, then select the maximum most solution. If the problem is the minimization, select the minimum most solution. So from feasible solution, find optimal solution. So that's it. This will be our flow. So this optimal solution will be our answer. This answer will be pertaining to the corner points which are dealing with the maximization or minimization, whatsoever the case will be for the objective functions. So this is the process which we are going to follow every time. Okay. So now let's start with, so is this thing clear now or any doubt in this, any of the steps?
Yes, sir.
Okay. Now let me just wipe out this whiteboard and I will be starting with the new method, Simplex method. Now, what can be the disadvantage of the graphical method? Can anybody say what can be the disadvantage of graphical method? See, but natural, we have discussed graphical method and then we are discussing simplex method. So, but natural, as the natural flow comes, graphical methods disadvantage can be solved in the simplex method. So, what are the disadvantages of graphical method? Okay, so Hum has to say long and time consuming. Prerna has to say points may be not clearly okay. Akshat has to say sometimes we not get the feasible region. Okay, so the answer for all these three things to the answer to Som's question or the point is long and time consuming. Definitely it's long and time consuming, but once we will be discussing about the this particular method, simplex method, it will be even highly time consuming because we won't be able to solve even one question in one lecture. So it is very long method, although the method name is simplex, but it's not simplex, it's quite complex method. Okay. Prerna's point is points may not be clearly visible. Definitely, it may not be clearly visible, and that was the reason I told that you need to find the intersecting points. Manually, you need to compute the intersecting points. Akshat is to say sometimes we know will not get feasible region. Okay, correct. It's not necessary that you will be always getting the feasible region. Now, but if you are not getting the feasible region, then that means your question doesn't have the optimal solution. So there are the chances that your question doesn't have the optimal solution. So there is a chance that your question even don't have the solution. So just to give this particular example, let me just say the real example that you might have faced. For example, you are going to purchase something. You are going into the market to purchase something. You are saying that I will be purchasing the particular product if you give me at a price less than 80. Suppose you are saying that, okay, you will be only purchasing the product if the shopkeeper gives you that particular product with the price less than 80. And the shopkeeper says that, okay, I won't be selling the product less than 100. So that means the product that the shopkeeper wants to sell should be of greater or equal to 100 rupees, and you are demanding that product for less than 80 rupees. So these are all the disjoint conditions. There is a disjoint conditions. In this thing, we don't have the optimal solution. In fact, if the shopkeeper says that, okay, I will be reducing by 10 rupees, you increase by 10 rupees, so you can have the bargain or intermediate stage to be of 90 rupees. But the shopkeeper is not ready to reduce his own profit, and the person is not ready to increase the or is ready to give more money. So this is nothing but the disjoint sets. So we don't have the feasible region. Karan is to say time taking. It may be possible that points are scattered. Correct. There are the points can be scattered, but still you need to find the corner point solutions. Mandeep has to say if you have three design variables, then it's not applicable. Right. So this is the important point that I will be considering from Mandeep, that for three or more, we don't have graphs. Or we don't have graphs. I won't be saying, but it will be not possible to have graphs because we are taking on each axis, we are taking one decision variable. On each axis, we are taking one decision variable. So for three or more decision variables, we require three or more dimensional graphs. Over here, we are taking two dimension graph only, that is X and Y. But for three dimension, even we can just afford to have three dimensional visualization graph or 3D graph, X, Y, Z axis. But what about more than three variables? There are the chances that a particular function may depend on more than three variables. So this is one of the disadvantage of graphical method. Another disadvantage, another disadvantage, Another disadvantage, major disadvantages that I will be considering is we are directly converting inequality to equality. We are directly converting inequality to equality. So this is not a correct mathematical approach. This is not a correct mathematical approach because if you are saying that okay, for this thing, let me just give one simple example. So I will be requesting everyone to just focus over here for the next 10 minutes, and I can assure that if you will be focusing, then it will be really easy to understand. Else, this method is going to be quite complex. As I already told, it is going to, quite complexities in it. Okay. For example, you are going to purchase 200-gram potato. You require 200-gram potatoes. So you are going to one of the shopkeepers saying that, okay, please give me 200-gram potatoes. Now, the shopkeeper is having the manual weighing machine. The weighing machine is not the digital electronics, but it's the manual weighing machine. And he has the gram weights of 50 gram, 250 gram, 500 gram, and 1 kg. He is having this four weights. He is having this four weights only. You are saying now that, okay, I require 200-gram potatoes. I require 200-gram potatoes. So in this particular stage, you will be having, this will be one of the pen. Let's say this is one of the pen. Just assume it to be the pen. I'm not saying that this is the pen, but just assume it. And this is another pen where you will be placing the weights. Over here, you will be placing the weights. Over here, you will be placing the potatoes. You told that please give me 200-gram potatoes. Now the shopkeeper says that, okay, I don't have 200-gram weight. So what I will be doing, I will be placing over here 250-gram potatoes. I will be placing over here 250-gram weight. For example, he is saying that, okay, I will be placing over here 250-gram weights, and I will be placing over here some of the potatoes. I will be placing the few of the potatoes. Now, if both of these things are in the equilibrium position, then it will be having the at the same level. If these potatoes are of 250 grams, then this both pens will be in the same level. That means once this both the weights are in the same level, it means the potatoes are of 250 grams. But I require the potatoes 200 grams. I require 200-gram potatoes only. So what I will be doing, I will be removing 2 to 3 potatoes. The shopkeeper removes 2 to 3 potatoes. So what happens? This particular weight on the right side moves down over here. This particular weight moves down over here. That means it's something imbalanced. Imbalanced. Now the shopkeeper says that, okay, you can now see that my right side weight is lower down and my left side weight is upper. The left side pen is at the higher position compared to my right side weight. So what will be happening that because of this thing, he says that, okay, now on the left side, the potatoes are equivalent to 200 grams. So are you all agreeing with this particular situation? What can be the disadvantage of this particular situation? We are looking into 200. First of all, what we did the balanceness. 250 gram equal to 250 gram. We did this balanceness. On both the sides, we just maintained the same equality level for the potatoes and the weights. Now I removed few of the potatoes and I made x1 gram of the potatoes over here. X1 gram of the potatoes over here, which is less than 250 gram. Which is less than 250 gram because I removed few of the potatoes. So my left side will be having x1 gram of the potatoes, which is less than 250 gram. So am I assured that I will be having 200 grams only? Am I assured of this thing? That I will be having 200 grams only. Okay, Deepesh is to say that sometimes it may be greater than 200 gram or less than 200 gram. Correct? Prerna says no, we are not assured about this thing. Fine. So that means this x1 is not guaranteed to be equal to 200. This x1 can be 180 also, this x1 can be 220 also. This x1 can be 180 also, this x1 can be 220 also. Now you are purchasing 200-gram potatoes, so you will be giving the money equivalent to 200-gram potatoes only. Now just assume that, okay, if x1 is 180 gram, then you are at loss. You are at loss. And if x1 is equals to 220 gram, then the shopkeeper is at loss because he is getting the money equivalent to 200 grams only. So what can be the win-win situation in this particular case? What can be the win-win situation in this particular case? Can anybody provide the solution for this particular situation? Okay, correct. So Prerna is to say checking x1 for 50 gram weight. Dipesh has to give some answer like a 200-gram potato with 50-gram weight, and on the other side put 250-gram weight. Okay, that's good. Yes has to say take 50-gram weights 4 times. Take 50-gram weights 4 times. Heth has to say 50-gram weight put in potato side and add potatoes. Karan has to say there should be inequality, not inequality. Fine. So we are having multiple solutions over here. We are having multiple solutions. So what the shopkeeper prefers, most likely to prefer, rather than to have 4 times 50 grams, rather than to have 4 times 50 grams, what he does, he adds this 50-gram weight over here. He adds this 50-gram weight over here. He adds this 50-gram weight over here, and he makes over here 250 gram. So now whatever potatoes will be there, it will be 200 gram. Whatever potatoes will be there will be 200 gram. So what we did over here, we were having x1 gram of the potatoes plus 50 gram is now equal to 250 gram. X1 gram of potatoes plus 50 gram is equals to 250 gram. So that means my x1 will be equal to 200 grams. So this particular case, I was having this one. X1 is less than 250. So how I converted to equality, I was in our previous case, we were directly putting inequalities and we were directly putting equality sign in place of inequality. But now we are adding something over here. So this particular thing is called in terms of simplex method, it is called as the slack variable. Slack variable. Slack variable. So for example, if we are having the equation like x1 plus x2 is less or equal to 250. So I will be not directly right over here x1 plus x2 is equals to 250. What I was doing was this one. But I can't convert or I can't change the inequality to equality in this format. So I will be including one slack variable, let's say S1. S1 over here will be the slack variable. So this is my slack variable that I will be adding. Similarly, just assume the other way around. This one, x1 plus x2 is greater or equal to 250. So In the same way, if I want to maintain the balance, I used to write x1 plus x2 is equals to 250. So in order to maintain the balance, what I need to do, I will be adding slack variable over here on the right side to provide the balance. So which on going the left side will be equal to minus S1. So this is nothing but the type of the equation over here is nothing but the slack variable. This is called as the surplus variable, excess variable, surplus variable. So this is how we can convert inequality to equality. In both the cases, if we are drawing the line, the graphical line, it will be the x1 plus x2 is equals to 250 only. But how can both the answers be this line? How can we represent with this line? So in the form of the mathematical equation, we would be using the slack variable or surplus variable. So in this type of the cases, we will be using the slack variable. In this type of the cases, we will be using the surplus variable. So we will be going to discuss this thing in more detail in our next sessions. But as of now, this is what we need to understand. So anybody having any doubt in this particular understanding? Anybody having any doubt in understanding this slack or surplus variable or what I was trying to say using this particular example? Those who are having doubt, they can ask the questions. Remaining can leave the session by writing their roll number and name in the chat box for the attendance. If you are having any doubt, then you are free to ask the questions.